Hello. Today we're going to continue with those complex numbers. Again, this week we are focusing on just kind of re-reviewing how those things work, and that'll continue into next week as well a little bit. Yesterday we went over just kind of the basics. How do you make a complex number, and then how do we add or subtract them? Nothing too major, but just need to get that back in our heads on how that works. Today what we're going to do is how do we do exponents of complex numbers, which feels a little backwards. We're going to do exponents today and then multiplying tomorrow. It's actually going to be a little bit easier to learn it in that order. Seems a little bit opposite. So it's kind of just little bits of multiplying today, but we're going to focus on exponents of just I itself, and then we'll go into more multiplying specific tomorrow. So just a little bit of reminder on what we had yesterday is that the square root of -1, that is I, that's that new number. So the kind of a next leading question is what might be I squared, right? What might that be? And so in here, I've kind of started that a little bit. I said, well, I squared by definition, I is just the square root of -1. So when we go to put in the square root of -1 squared, right, when we go to square that, you guys know that if we square something, right, that removes the square root. It just sort of undoes the square root. So now we got to be a little careful though. This does not become 1, right? A lot of people think that whenever we square something, it becomes positive. That's with real numbers, right? We're working with something a little different. We're working with the complex numbers right now. So this squared just cancels the square root. It does not cancel this -1. This squared and the square root, that's the only things that cancel each other. So when we get all said and done, we just get -1 as a result because it only cancels the square root. It does not cancel that part. It does not cancel the rest of that. So we just have to be a little bit careful there that that's going to be -1 in here because it just cancels the square root and leaves us with that. So that's kind of the key takeaway to remember. I squared is equal to -1. You don't have to necessarily memorize all the rest of what we're going to go over. You can kind of rethink through that. It's not bad to memorize it, but this is the one thing we should have memorized. I squared is -1. If you remember that, the rest of it's pretty straightforward, not too bad. So we can keep going up, right? I squared is -1. I wonder what I to the third power would be. So I might look at this, I to the third power. I wonder what that's going to be. Well, here's what we do. We take this and say, well, I times I. There's I squared. You guys know what that is, right? I times I is -1. And then you have just an extra I hanging out. That's I times I right there is -1. So that just equals -I. That's exactly what that is. Nothing super exciting. We'll see if it puts it in there. All right, nothing super fantastic there, but that's what I times I is this -1 here. So then it's just -I, right? So I cubed becomes -I. Kind of strange. And again, it seems a little different than what we're used to working with. When you cube something, it all of a sudden automatically makes it negative, but that's the way that works with these complex numbers. So if we pop up to the next one, right? I to the fourth power. Well, here we'd have I times I, and another I times I, right? Thing we should remember, I squared is -1. So this should become -1 times -1, which is equal to +1. So I to the fourth power becomes +1, right? That's what we would have there. Let's take these two guys. Let's see if this ends up working out here. Maybe it's not going to put that picture in there. It doesn't want to do that. Oh, all right. Now I'll have to restart that and get that stuff in there. Oh, well. Okay, there it finally worked. Let's see. So, but that's where those pieces are coming from. I times I is -1. I times I is -1. And then we can remultiply them. We finally get +1. So I to the fourth is +1. And then we could keep going, right? We could keep going with these types of things. Now, here's another one to kind of keep in mind. You don't have to memorize, but I'm going to utilize this. I know that I to the fourth, any group of 4, is actually equal to +1. So if we go to I to the fifth, actually here, there are four i's right there. So this is really 1 times I, right? 1 times I. So this one in itself would just I to the 5th would become I again, right? And there it's a little bit different, but that would become I. All right, that's all that that one would be. Nothing too exciting there, but that's all it would be there, right? It just become I. In this one here, again, any 4 of them are going to become 1, right? That's all that's going to become. And same thing down here. I suppose I can just, oops, let's not take that whole thing. We just want this one. Same thing here. Those are going to go. Those are going to go, right? Oh, and this one actually has 2 sets of 4. So like I to the 8th is going to be 1 times 1. I to the 8th is actually just 1, right? We can figure out the other ones as well, but I just figured I'd kind of group those sets of 4 there together, right? So here, this is 4 of these. And then, well, hey, wait a second here. Let's take this. This has 3 of these i's, I cubed. All right, let's put that in blue. Now we know that I cubed, we figure out before, is actually negative I. So in this case here, this stuff becomes negative I. We sort of get that again, right? So we get this sort of repetition to keep happening. We can see here, oh, I squared, right? Again, that's one that we should have memorized. We should know that I times I itself is negative 1, right? I squared is negative 1. So that one becomes negative 1, right? We can keep going and going and going. Now, I'm not going to do more and more of these here. I think you guys have that down pretty well. But that becomes negative 1 on there, right? So in here, really, any exponent that we would have on I can always get reduced down to one of these 4 things. I, negative 1, negative I, or positive 1. That's it, right? Anytime you see an exponent on I, it is not simplified. We should always be able to simplify it down so that it only has an exponent of 1, or I suppose exponent of 0, right? So we can simplify it down. So here's kind of a way to look at it, right? Now you can, write this down somewhere. You can have this kind of handy. You can look at this, I to the 0 power is 1. Anything to the 0 power is 1, i's included. But, I to the first power is obviously I, and then here's the ones we figured out. And then it kind of circles back around again. We get 1, and then the next one's going to be here, I to the 5th. So one way to, you can memorize this stuff. That's perfectly fine. You can kind of write this down or remember that. But one way I find it a little easier, because I like to visualize how things are sort of mapped out, is we can sort of map it, right? This is a way that I find a little bit easier to map out. I would start over here. I'd say, okay, actually, I to the 0. Let's see if we can't. Doesn't have a fill option, huh? Okay, so I'll put it back here. So here's where we would have 1, right? I to the 0, I'm just going to start over here at forward 1. Well, the next one I'm actually going to place up here, right? I to the 0 equals I, and kind of say, well, that's where it would jump to. There's I. 1 turn. And then the next one's negative 1. Well, if this positive 1 is off to the right, negative 1 should be off to the left. That's going to be over here. And so that's sort of just another turn on this one, right? We're just turning down to the next one, another 90-degree turn. And then if positive I is up here, negative I should be down here, right? So I'm going to put this one down here. Here's negative I, right? And that's just another turn. And then our last one, right, should take this and it should basically bring it right back. I to the 4th is positive 1. That's back here. And so this is the way I like to think about it, is that it's just kind of rotations moving around in sort of a circular order. Positive 1 is to the right. We just start there. And then here's 1, I to the 1st, I to the 2nd, I to the 3rd, I to the 4th, 5th, 6th, 7th, 8th, 9th, 10th, 11th, 12th, 13th, 14th, 15th. You can just keep spinning around in a circle. And then wherever you land up, that's where it's at, right? So that can be a way to kind of visualize how these exponents work. If you want to use that, you certainly can. If you don't want to, and this makes sense to you, that's fine. So here's just a little bit with simplifying some of these things here. Yeah, what we would do, like we said, every 4 powers, it sort of repeats itself. So what we can look at is divide just take that exponent, divide by 4, take a look at the remainder, and then see where it's at, right? So for example, here, if I wanted to do I to the 12th, I would take 12 divided by 4 and see that I have, well, I'm going to put here actually equals remainder equals 0, right? I'm not going to take a look. I get 12 divided by 4 is actually 3, but there's nothing left over. The remainder is 0. So that means what would have happened is this is the same as doing I to the 0 power, right? It's the same thing. So the final value on this one is 1. I know what that is because I to the 0 power. If we did 51, okay, that would be the same as doing 51 divided by 4 and seeing what is the remainder. Okay? And the remainder here, and when we do 51 divided by 4, is actually 3. So this would be the same as doing I to the 3rd power, and we get negative I in that case. And if we weren't sure on that, we could go back and look and say, okay, 1, 2, 3 turns, that's negative I down here. So that's what I would put. And you can do that for the rest of these here too. Take 209, the remainder, I'm not going to write out the dividing, and take 209 divided by 4, we'd have a remainder of 1. So that's the same as I to the 1st power, or just I, right? And so on there. And I'm going to make these just a little bit bigger, and let's actually make them so we can kind of tell the difference between a 1 and an I on that spot. Okay. So there's a remainder of 1. And same thing, it doesn't matter how big the thing is, you just divide it by 4 and see what's the remainder, right? In this one, the remainder is going to be 3. If you take 5,271 divided by 4, you actually get a remainder of 3, and so that will be just negative I will be the result there. And like I said, this big, huge thing, divide it by 4, see what the remainder is. In fact, here you should see this is perfectly divisible by 4, so we know the remainder is equal to 0. So this big, huge number becomes 1 because it's the same as I to the 0 power, which is 1. And so that's how you do those with remainders. The last piece we're going to go over today is, what if we had negative exponents? How do we do negative exponents? Well, the idea with negative exponents, and I've kind of put the answers over here, is we're basically going to take this thing here, right? So let me just copy that. Positive powers, we go in the positive angle direction, right? It goes in the positive direction. If we have negative powers, well, all we're going to do on this is we're just going to switch the direction around. So all I'm going to do here is actually just turn each one off and change direction. That's it. It's just changing the direction we go. So actually, I to the negative 1 power, usually we'd go up this way. Negative 1 power means we'd reverse direction, and that would be down here, right? It's the same. I to the negative 1 is the same as I cubed. And then I to the negative 2 is negative 1, because that would come up to this spot, right? And then I to the negative 3 power would go up here, right? We're just reversing direction. I to the negative 4th, again, would come back this way, okay? So if you have negative powers, you do the same thing. Here, if we tried to divide this by 4, our remainder would be negative 2 in this case, right? That would be our remainder. So then the final value, I could again go here, back 1, back 2. That's actually negative 1, and so we can go through there. Here we just find the remainder each time, right? Negative 99 gives us a remainder of negative 3. So that would give us actually a value of positive I, because that's up here. Here's negative 3. 1, 2, 3. I'm moving backwards again, right? Because it's negative. And same thing, if we did this type of thing, this has a remainder of negative 1, right? Spelled that wrong. Well, I'll fix it here in a second. But the remainder of negative 1. So in here, that would actually be negative I when all said and done in that. But that's with exponents. We can think about them, divide them by 4, look at what the remainder is, and then put their result there. So just like yesterday, your guys' assignment is actually attached, on a separate page. So if you want to format it, actually, this one's probably not too bad for formatting. But if you do, it's just attached on a separate page as well. And again, if you guys got any questions, you guys have been pretty good about sending them my way, but keep up the good work. See you later.